Hi, my name's Dan, and this video is one in quite a long series of videos in which I'm charting the progress of making a 4-bit CPU, a simulated 4-bit CPU from basic logic gates all the way up to a working programmable CPU. I'm using this software, which is DigitalWorks, which is free to use, and a link to where you can get hold of it is in the description down below, as is also a roadmap of where we're going. Excuse me, and we're quite late on now in the progress of this. We've done a whole lot of fairly generic stuff. We've created a whole lot of parts here that we can use that are macros, and we're working on the control unit, which is a fairly high level piece of hardware in the CPU. Um, Quite a bit of what we're doing won't make sense to you unless you've watched some of the previous videos. Even if you have a good understanding of what's going on inside CPUs, we have started to get quite specific to this specific CPU design. So the control unit that I'm creating is very specific. Some of the um, uh, some of what we're doing will be more widely applicable, and the principles of how we think about things obviously are quite widely applicable. But I think the best benefit for this video is for anybody who's actually playing along with me and creating this thing for themselves. It's quite a satisfying thing to do to create a CPU. Um, so in the last video, we did a bit of talking about what the control unit is and what the control unit needs to do. In this video, we're going to deal with the fetch part of the fetch execute cycle. In other words, we're going to get the control unit to load uh, information from the memory banks. We're going to load in the data and the op from the two memory banks. So if you remember, if you've been following through again, we've got two memory banks. We're using a modified Harvard kind of architecture in that we've got one address register that accesses two separate memory banks. The first thing I'm actually going to do, though, is I'm going to start setting up the control unit. One of the features of the control unit is that there's a lot of output pins. And in order to make life easier further down the line, I'm going to be quite organized about this. So I'm going to set up um, uh, quite a few of those output pins to start off with. And I'm going to do them in a kind of in a way that's a bit like a bus, but they're not. So I'm just going to put some tags in. And what I'm going to do is I'm going to make these lines that I can tap onto down at the bottom. And to start off with, I'm going to have, on the left-hand side, I'm going to have output enables that can go to the various registers. And on the right-hand side, I'm going to have bus reads that can go to, that similarly can go to various. And I'm going to stick an LED on this. I quite happily tend to connect a tag to an LED, even if you're not going to ever see that LED. It's kind of nice to know it's there in case we'll have problems later down the line, and um, we want to be debugging what's going on. We can dive into the macros and see the status of things using the LEDs. We've got 9 registers, so I need to obviously make 9 lines. Having said that, actually, not all of the registers do both input or need to have both input and output effectively. So what we'll do is we'll put them in, and then we'll take out any that are unused when we get to the end. 1, 2, 3, 4, 5, 6, 7, 8. I'm being fairly neat because it's going to help us. So that's one set. I've got to copy that whole lot to create a second set. I need to be quite careful how I grab hold of that so that I do grab something that brings the whole group with me. They may not be wide enough. I'm not quite sure yet, but we'll work this out as we go along. I have gone through all this process before, but I'm taking the opportunity of doing it again to change some of the layouts of how I've made things. So some of it I'm seeing how it goes as we go along. So let's list down here the different registers that we might need to talk to. Um, uh, and as I said, there are 9. So first of all, there are 3 that are connected to the memory. So we've got MAR, which is the memory address register. And we've got 2 memory banks, so we've got 2 MDRs, which are the memory data registers. And I'm going to call them MDR0 for the operations register and MDRD for the data register. MDRD. Okay. So we've also got the op and the data registers, which we're going to load the information from the memory into op, and we'll tidy these up in a minute. Data, and we've got the program counter. And then we've got the ones that are to do the ALU. So we've got the A register, the B register, and the output, which is called ALUX. Okay. Hang on, Dan, I hear you say. What about the flags from the ALU? And my answer is that the flags don't need to connect to the bus or either of the buses at all, because they're just hardwired into the control unit. I'm just going to spend a few seconds doing a little bit of lining up. Again, I'm being somewhat neat. I have this tendency to, obviously when I'm testing things, you'll have seen that I can be quite less bothered about neatness. But where there are large numbers of wires, like there are here, the more complex something is, the more I tend towards wanting to be neat in order to make it readable at some point later in the future. So what I've just done is I've done a cut and paste, sorry, a copy and paste for that list, so that we've got the same list over there, and then over here I'm going to write OE for output enable, and I'm going to bold though that, and then this is bus read over this side. Bus read. Okay, we will need more as well. We'll need we could set them up now. There's no reason why not. We need a halt. We need. The reason why I'm highlighting these is actually I'm thinking I need to work out how many I'm going to need. We need a halt. We need memory read and write for both of the memory banks, and what else? Oh, we need an execute for the ALU. So that's 6 in total. 1, 2, 3, 4, 5, 6. So I'm going to create those and label those whilst I'm at this process. I think that's probably going to be all, but if we need any more, we can obviously create more. And I'll just stretch that out and put some labels in. So take bold off for that. So I'm going to call this read. I'm going to have read O and write O, and read D and write D for the 2 different memory banks, which just keeps it consistent with the rest of my terminology. Read D. Right D. And execute for the ALU. Okay. Once again, just do a little bit of tidying. Oops. I've still got the text tool highlighted. Right, so fetch 1 and fetch 2. We need tags for them as inputs. And again, let's label them. So it's about 9 points, not 10. Oh well. Fetch 1. And fetch 2. And all we need to do actually is just wire these up to the right outputs. I say all, it's not actually all, because there's a little anomaly with the simulator in that if you're using macros, hardwiring an input to an output causes problems. And it's probably must be something to do with the way that the simulator works. And the solution to it is to actually just stick a buffer to separate them. However, there are no buffers, so we're just going to use AND gates and connect the inputs together. So, a bit more wiring. So fetch 1, which is the first phase, we need to copy the PC, which is the program counter, to the memory address register. So we need to, I'm just shuffling everything across. Yeah, it'll do. So that's the output enabled from the PC, and bus read from the memory address register. And we also want to tell both, in fact, of the memory banks to read at this point. So we're just going to connect those together. Read out and I'm just thinking about, no, it's fine. I was just thinking about the fact that that then means if something else connects to read out, it automatically does read D as well. But actually, this isn't true, because if we have more than one thing that wants to connect to one of these outputs, I say at the moment it would look like we could just drop down lines as far as many as we want. Actually, that's not quite true, because if we have more than one going to the same line, we're going to need to stick an OR gate in, because you can't connect two outputs together. So that should be our fetch 1. I'm just going to slightly obsessively tidy that up a little. It's not quite what I wanted. Okay. And then fetch 2 is 2 memory reads, and what we need to do is we need to output enable from both of the memory banks, so that's MDRO and MDRD. That's one. That's the other. And at the same time, we want to do data read, so bus read, sorry, for both op and data. And the reason why we can do this, if you remember, is because we're actually using a separate bus for op, so that the MDRO is connected directly on a bus to the op, and the data, so the MDRD, goes on the main bus. Right. That should be that. We're not at a stage where we can actually test this yet, because we're going to need to do a test setup for the whole of the control unit when we put it together later on. So at this point in time, we just kind of need to potentially trust and hope that we've got it right. But let's just do a visual check and a think through just to check what we've got. So fetch one, at this point we want to get the address from the program counter and stick it into the memory address register, and also make it so that the both of the memory banks do a read operation. So let's check that that is what we've actually done. We've done output enable, so I deliberately put output enable on the left and bus read on the right, so that this is the one that we're going from, and this is the one that we're going to. It's the opposite way around from register transfer language, but it is the way that I tend to think about it. So we're output enabled from the program counter, which is correct, and we're bus reading from the memory address register, which is correct, and we're doing a read from the ops memory and a read from the data memory. That seems correct. And then phase two, so this happens once we've effectively fetched halfway. We've fetched the op into MDRO and the data into an MDRD. So output enabled from both MDRO and MDRD, and bus read from op and data. There we go. So that's it for our setup and for our fetch. In the next video, we're going to do the decoder for the operations. But that's it from me for now.